Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to a special edition of the Observer's Notebook podcast, the official podcast of the Association of Lunar and Planetary Observers. I'm Tim Robertson, your host, and I want to thank you for joining us. And a special welcome goes out to all of our new listeners and viewers. Thank you for finding us. Hope you enjoy the show and become a special part of our growing community. This podcast is made possible by the support of our listeners. You can help keep the Observer's Notebook going by joining us on Patreon. For as little as $1 a month, you'll be supporting the show. For $5, you receive early access to the podcast before it goes public. For $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you'll be recognized as a producer of this podcast. You can find out details at www.patreon.com/Observer's Notebook. And to learn more about the ALPO, visit our website at www.alpo-astronomy.org, where you can join the organization, and membership begins at only $22 a year. And now, let's dive into this very special supplemental episode about comets on the Observer's Notebook. Enjoy. All right, I'd like to welcome everybody back to this special supplemental edition of the Observer's Notebook podcast. And we're talking comets, and that means we're talking to Carl Hergenrother. Welcome back, Carl.
Hi, Tim. Thanks for having me.
Yeah, now we chatted about this because we got some interesting comets coming very soon, and some are visible right now in the sky. So that's what we're here to talk about. So why don't you give us a little update on them?
Yeah, so the last time we talked about comets, which was near the end of 2024, we were talking about the predicted comets for 2025.
Mm-hmm.
And at that time, 2025 looked like it was going to be sort of a down year for comets, that there wasn't much expected to be bright. In fact, there weren't really going to be any good comets to see with typical backyard telescopes through most of the middle months of 2025. As it turned out, we had a potential, what some people are considering a great comet in January 2025.
Mm-hmm.
If you're wondering how you missed that, you lived in the Northern Hemisphere, it's because that comet, C2024 G3 Atlas, was more of a Southern Hemisphere object. It was visible from the Northern Hemisphere for a few days, low in the evening, still, fighting against bright evening twilight. But it was 0th magnitude, -2 for a day or two, and it was a nice sight in binoculars. But we didn't see the full glory of the comet, which was seen down in the Southern Hemisphere,
Mm-hmm.
with 10, 20-degree long tail. The nucleus disintegrated a week or so after perihelion. So in fact, the comet ended up becoming what they call a headless comet, which meant it was, no head, all tail.
Okay.
But you could still follow that tail. In fact, there's still observers as of a few months ago, or weeks ago, and maybe even still now, who are still observing the remnant dust, kind of the ghost of that comet as it goes out.
That's interesting.
But then there was not much to see for most of those middle months of 2025. Luckily, we've had a few discoveries. Most people have heard of 3I Atlas, which is the third known interstellar comet. Not a bright comet by any means, not something you're going to see with your eye or even with your typical, small refractor or whatever, but an interesting comet nonetheless.
Now, when you say interstellar comet, explain to our listeners what you mean by that.
So most comets, almost all comets, except for these three, all bodies, were born in our solar system. I'm not even going to say probably. Were born in our solar system, are attached to the sun, and continue to orbit the sun. We do see comets that go around the sun that are originally from the solar system, but then because of interactions with the planets, mostly Jupiter and Saturn, get an extra kick and get thrown out of our solar system.
Okay.
Become hyperbolic comets, and they leave our solar system. Well, every other stellar system in our galaxy is doing the same thing. They're throwing comets out on a kind of routine basis. And we were always wondering when we were going to run into one of these interstellar comets that was traversing the galaxy and making a close approach to our own sun. So if you remember, a couple years ago, there was an object discovered by Pan-STARRS called Oumuamua.
Mm-hmm.
And that is an object that, though looking at its orbit, it appeared to accelerate, which is something comets do. For everyone else's images, it didn't, it just looked like an asteroid. And that was the first known object that came from outside our solar system, was born around another star. It was passing through our solar system.
And that was cigar shaped, wasn't it?
That's the thinking based on its light
Okay.
curve, is
Okay.
that it was not even just, not necessarily, it's cigar shaped or even like a flat kind of oblong pancake or something like that, because it had an extremely high amplitude light curve.
Mm-hmm.
Something you really can't get unless you have an extreme shape, extreme stretch to the object. And then a few years after that, there was a comet called 2I Borisov, which got up to about 14th, 15th magnitude as it passed by the Earth. And then this year, we've got an object called 3I Atlas. Originally, it was C2025N1 Atlas. Also a comet like Borisov. And this object holds the record, as for now, with the highest eccentricity relative to the sun of a little over 6. If you know most comets, the eccentricity for periodic comets is less than 1. For parabolic comets, it's around 1, exactly 1. And for hyperbolic comets, it usually gets no greater than 1.05, 1.06, and that's only if, Jupiter or Saturn gives it an extra kick. So this is an object that is almost traveling in a straight line around, through the solar system. There is a bend to it, but it's a lot closer to straight than you're used to. So this is an object that obviously was formed around a different star. Some initial analysis suggests that it came from a population of stars that are older than our sun.
Wow.
So it's possible that this comet is older than our own solar system by maybe a few billion years. That doesn't mean it's been moving around the galaxy for a few billion years.
Mm-hmm.
It could have been ejected from its star 5, 10 million years ago, but its original creation was quite a while ago. So the first comet of our trio is C2025 R2 Swan. This was discovered by a Ukrainian amateur, Vladimir Bazulgi, who was using the SOHO publicly accessible data from the SOHO spacecraft. SOHO is a NASA/ESA spacecraft that's been up there for a few decades now, that observes the sun routinely, not only the surface of the sun, but also the region around the sun. And one of its instruments, the SWAN instrument, actually covers the entire sky and maps hydrogen alpha. And mostly it's for studying the outer atmosphere, solar wind, corona of the sun, but it's also pretty good at detecting comets once they get brighter than about 10th or 11th magnitude. So he was looking through the data, and in the beginning of September, noticed that there seemed to be a slowly brightening but moving object, and reported it as a new comet. Around the same time, there were other observers who were commenting on the comet's mailing list that there was this bright comet with a long tail in images taken by another sun-watching spacecraft, the Stereo mission, which is another, there used to be 2 Stereo spacecraft launched by NASA. One unfortunately failed, but the other one is working as well. It's still working. And so here we got this new comet that somehow snuck up on us, mainly because it was approaching us from the far side of the sun, where it wasn't going to be seen by the ground-based asteroid surveys. And there's also some evidence to suggest that it was rapidly brightening, so it may have been pretty faint when it was discoverable from the ground. So when this comet was announced on September 12th, it was already at perihelion of about 0.5 AU from the sun, so that's half the distance between the Earth and the sun.
Yeah.
And it was around 7th magnitude. As you can see in the light curve up at the top, it was still brightening a little bit even after it was initially reported. But towards the end of September, it had about a 1 magnitude outburst. So it's currently around magnitude 6. Now, right now, the comet's currently only a southern hemisphere object. I've tried looking for it on 5 or 6 nights here from Tucson with, the clear horizons, clear skies, and I still haven't seen it from the northern hemisphere.
Okay.
It's funny that in my 5 or 6 attempts, I've seen 2 SpaceX launches, but no comet, at least in the evening. One of both launches I wasn't even prepared for, which was a kind of a nice surprise. But the thing about this comet is that it's swinging around the sun and it's rapidly approaching the Earth. And in fact, towards the end of October, on October 20th, it's going to pass within 0.26 AU of the
Wow.
Earth.
Wow.
And so even though it's not visible right now from the northern hemisphere, even though from the southern hemisphere you're able to observe it visually, during October, and that's the numbers you see under the 40N in the ephemeris near the bottom of the screen.
Yep.
It's the height of the comet in degrees at the end of astronomical twilight.
Okay.
So you'll see at the beginning of October, it's still not above the horizon in astronomical twilight. But as you get towards the middle of the month, it's about 20 degrees up. And by the end of the month, it's close to 50 degrees up. And also, because even though it's moving away from the sun, it's still, bearing down on the Earth. So it should brighten. So right now it's around magnitude 6, and it should stay between about magnitude 6 and magnitude 7 through at least the first half of the month. And it should fade afterwards towards 8 or 9 as we get towards the end of the month. But what's cool about this comet is just how nice it looks, at least in images that we've seen.
Mm-hmm.
It's definitely, first of all, it's not a periodic comet in the sense that it comes around every 5, 10, or like Halley, 76 years, but it's definitely a long period comet that has come around before. And based on its orbit, the last time it was at perihelion was about 650 years ago.
Okay.
So it does come around quite a bit, which could explain why it brightened so quickly. It could also explain why, for an object that intrinsically is not the brightest of comets, it's still holding together. Usually comets that have been around a few times have a habit of sticking. Usually comets that have been around the sun a few times are not prone to disintegrate, unlike comets who are making their first pass to the inner solar system. It's definitely a gas-rich comet with a nice long gas tail. And the tail is up to
Wow.
about 2 degrees long, as you can see in this picture here by Gerald Riemann and Michael Jaeger. That's actually the bright star Spica there.
Okay.
Mars was just if they went to like another field, you would have had Mars up there as well. But that's about a good 2, 3 degrees of tail. Here's another image that shows even longer tail. It's an 8-degree field of view from one
Oof.
end to the other by Michael Mattiazzo down in Australia. And you can easily imagine at least 6 or 7 degrees of tail here. And as you can see, it's kind of got the swirliness that you see with most ion tails.
Mm-hmm.
Kind of to go back, we start here on the 13th, and you've got the ion tail, but there's also the beginning of a dust tail, which is this broader tail here. And as we progress, you can start seeing the dust tail extending out even further, and now almost to the end of this field of view. And so you've got the growth of some dust going on as well, which is really good. It shows it's a nice, healthy comet. And it definitely should be something that should look nice in, good small binoculars or small telescope through the month of October in the morning sky. And there have been observations made from the northern hemisphere. This Michael Olesen, not too far from where I am here in Tucson. Even though I haven't seen any reports of anyone seeing it visually from the northern hemisphere, it's at least imageable from the northern
Okay.
hemisphere. This was taken with a Red Cat 91. This was another one in color with the same Red Cat 91. And all these comets are they're not really close to each other, but their line of sight is similar. So here's an image of Swan, and up here in the upper right corner is actually 3I Atlas. So
Oh.
the two had a nice conjunction back on September 27th. And just to show you, it's basically coming out of the sun, which is why it was discovered by the sun watching spacecraft. And then it moves through Libra, Scorpius, Ophiuchus, into the northern part, basically into Scutum here, just north of Sagittarius, into Aquila, and will end October in Aquarius. So it's
Okay.
basically moving directly away from the sun.
Okay. Wow. So we probably got another month easily.
Yeah, at least another month here. And so for the next few days, for the next few weeks, it should be doable in the evening sky, about 6th, 7th magnitude.
Okay.
And then by the end of the month, especially right after it's past its close approach, you're going to see the brightness just kind of dip down.
All right. Cool.
But that at 6 magnitude sounds bright, but it won't be the brightest comet of October. The brightest comet of October will be C2025 A6 Lemmon. Like R2, this was a comet we didn't talk about when we did our Comets of 2025 podcast last time because they hadn't been discovered yet. 2025 A6 was discovered on only the third day of the year, on January 3rd, by the Mount Lemmon survey. Again, just out the window here, I can see the Mount Lemmon out there.
Okay.
They have a 1.5 meter. And this comet, when it was first discovered, was pretty faint. It was a 21st, 22nd magnitude comet. And in fact, for the first few months of the year, it didn't show much brightening at all. It acted as if it was a bare asteroid. So it's possible that we were seeing mostly the nucleus when it was being imaged. Obviously, it was designated as a comet because there was a little bit of a tail observed with some of the really large telescopes. But it's likely that it was mostly just bare nucleus with a little bit of coma and tail. And then it went behind the sun at solar conjunction in April. Actually, April's when we lost sight of it. Then it had solar conjunction in June or something like that. And we didn't see it again until August. And based on its slow rate of brightening in the beginning of the year, we weren't expecting it to be much brighter, about 18th, 19th magnitude. So surprise, surprise, the first images of the comet showed it at about 14th magnitude. And then very quickly over the next week, it 14 became 13, became 12, became 11, became 10.
Wow.
And it's obvious that the comet had turned on and was rapidly brightening. And so by the end of August, here was a comet that was a nice visual magnitude object around 10th magnitude. Since then, it has continued to brighten, and it's currently around magnitude 6.5. It's a morning object. If you go out, you'll find it in the constellation of Lynx. It's about to go into your Ursa Major, just to kind of show where it is on the sky. So right now it's in Lynx, kind of clips Leo Minor, and then it's in Ursa Major. And it races, even though it's a morning object, you'll see that it starts becoming an evening object around mid-October. And the reason for that is because it's north of the sun and is traveling up and over the sun,
Okay.
which you can also see here because it's got a retrograde inclination, 143.3 degree inclination. So it's going around the sun in the opposite direction that the Earth is. So as the Earth is moving this way, the comet's racing in the opposite direction. And so it's a morning object, races north of the sun, and then becomes an evening object. Unfortunately for the Southern Hemisphere observers, this one is really only a Northern Hemisphere object. It's because the inclination is such that it's above the sun, so you can only see it from the Northern Hemisphere. Perihelion won't be until November 8th at 0.53 AU, so about the same distance as R2. It's closest to the Earth a few weeks before that at the end of October, on October 21st at 0.60 AU. And like R2, which has a 650 year or so orbital period, A6 also has a relatively short orbital period, and that it goes around the sun roughly every 1,350 or so years. So this is another object that's been around before. I've seen it in my 30 by 125s. I've seen it in my 10 by 50s, and it looks like, the Hercules globular. It's a nice, condensed, unresolved globular star cluster is what it looks like in these small aperture instruments.
Okay.
And that's what it looked like, especially in the beginning of September to a lot of people. But towards the end of the month, and those people who are taking really long exposures or have large apertures, it looks very similar to R2. And that, again, we've got this nice, long, dynamic tail.
It really does.
And the beginning of a dust tail here as well. And this is for a comet that still doesn't get to perihelion for at least another month and a week.
My goodness.
So it's going to get even better. Um, Christian Harder was using a 21-inch Dobsonian, 112 power, about a week ago on September 21st. And you can see a tail with his 21-inch Dob. A little close-in shot on the same day. Dan Krausen using a telescope out in Missouri. Oh, actually, no, he's in Missouri, but the telescope's in New Mexico.
Yeah.
And then here's images again showing the comet's tail. And it's kind of dynamic
Hmm.
raggedness to it as it, is buffeted by the solar wind. And here's September 22nd, Dan Hartlett, nice round,
Hmm.
aquamarine coma, and then that beginning of that dust tail.
Another green comet.
They're all green.
I know.
That's the thing. They're all green. And of course, sometimes you look at these comet pictures like, wow, and you go like, oh, check out that galaxy.
Yeah, I know. I'm looking at the one up at
And then
that.
yeah, that's pretty cool up there. And September 30th, it's only a few days ago. And again, you can see this kind of reddish, yellowish dust tail that's forming and moving. And then the last picture was taken on October 1st, so we're only talking yesterday.
Okay, great. Wow.
So how bright will this comet get? So right now it's brightening at a pretty rapid rate, around 10 log R, which is what we used to assume all comets brightened
Hmm.
at. Um, if you assume it's going to slow down in its brightening trend, which is very likely, you're still talking about a comet that will probably brighten to around magnitude 3.8, magnitude 4. And that's at the end of October. One nice thing is the comet will get to slightly large phase angle by then, phase angle of between 100 110 degrees.
Okay,
So there could be about a half magnitude of forward scattering dust enhancement, so another half magnitude on top of that. So it's possible you could be talking about a comet that's maybe magnitude 3.5, which is pretty nice.
that's nice. Yeah.
And by then it'll be an evening object, not the highest comet, 16 degrees, maybe 18 degrees above the horizon at the end of astronomical twilight. But still, for the northern hemisphere, that's pretty well placed
Yep.
for a bright comet. So no quibbles there. So yeah, that's C 2025 A6 Lemmon.
Okay, great.
And then the last comet to talk about is, of course, our interstellar comet, 3I Atlas. So this was discovered by the Atlas project, and Atlas is an acronym. It's one of NASA's asteroid survey programs, and it's an acronym for Asteroid Terrestrial Impact Last Alert System. And they have a bunch of half-meter F2 Schmidt telescopes located in Hawaii, Chile, and South Africa. And it was one of these telescopes in Rio Hurtado, Chile, that actually discovered this object on July 1st. Though there were observations made even by the Vera Rubin telescope during its commissioning for about 10 days there. They actually had images of 3I Atlas, and there were other groups that imaged it back to May. So even though it wasn't discovered till July 1, there were objects going back to May 8th of this particular comet. It gets pretty close to the sun, 1.35 AU.
Hmm.
Unfortunately, as you can see from the orbit diagram there, and this orbit diagram is valid for the perihelion date, which is October 29th, it's on the other side of the sun from
Yeah,
the
and
Earth.
like you mentioned before, it's almost a straight line.
It's almost a straight line as
Yeah,
it's going through there because it's
it's
got
a
an
chart.
eccentricity of 6. It's kind of just barreling high velocity. Obviously, the sun's gravity is deflecting its trajectory a little bit, which is why
Hmm.
it's not exactly a straight line. But yeah, it comes and goes very quick as it moves through the solar system rapidly.
And that's probably why we really won't see a tail on the thing.
Well, part of the reason we won't see a tail is because, yeah, if you see from this direction, we'd be looking along if the tail is pointed away from the sun, we're kind of looking along that direction
Okay.
because we're also, looking in that same direction. But when I show the images of the comet, you'll see that there is a little bit of a tail there. One thing about Atlas was that when it was first, when we first picked it up, when everyone started observing it in July, through about September 1st, it was brightening at a fairly nice rate. If you take into account the phase function, It was discovered near opposition, and then over the next 2 months, it went to higher and higher phase angle. And because of that, that made the dust in the coma look fainter. So if you didn't take into account the phase
Okay.
function of the dust, and you plotted up the light curve, you might go, oh, this object isn't getting brighter at all. It's staying constant state. But in fact, if you take into account the fact that the phase angle is increasing and there's a phase function there, it actually has a fairly normal brightening trend. But then that all changed in the beginning of September. And as you can see in that light curve, you kind of had this uptick in
Hmm.
brightening. And that also corresponded when the observations before September 1 only showed a dust coma in the beginning of a dust tail. Observations after September 1 showed the rapid development of a gas coma. So this could also just be, and we see this with other comets, not just interstellar comets, where you're just seeing dust, 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 and then when the comet really turns on, when you can start getting water production, because you've gotten within 3 AU of the sun or so, you start seeing the development of a giant gas coma, and you see the brightness really take
Okay.
off.
All
And I
right.
think that's what we're seeing here. That does suggest that the comet, which was originally predicted to only peak at around 13th magnitude, could get as bright as 10th magnitude. Now, before you erase, go, great, I'm going to go outside and look at it visually with my telescope. Notice that when it's at its brightest, it's 2 degrees from the sun.
Hmm.
So we're going to have to wait till really November from the northern hemisphere, and probably more like December from the southern hemisphere, when the comet's far enough from the sun in the morning sky that you'll be able to actually see it. And by then, it probably won't be 10th magnitude, it'll be more like 11th or 12th
Okay.
magnitude.
And that's what the chart is showing there.
Right. And so, unfortunately, on this chart, and all these charts were created from inthesky.org, which, just to put a little plug, is I find it really useful for picking up, making start. That and Stellarium are kind of like my two go-tos for figuring out where to look in the sky to
Okay.
see comets. Unfortunately, the sun isn't shown on here, but you can kind of tell from the direction of the tail that the sun's down here by Spica, and then 3i goes through conjunction. So unfortunately, the sun isn't shown on the chart here, but you can see kind of by the direction of the tails where the sun would be.
Hmm.
And so the sun's down here in Virgo, and on October 1st, the comet is on the evening side. By the time we get to November 1st, the comet is now on the morning side. So it's passed by the sun. And then as we go out into the morning, it climbs higher and higher into the sky. If you notice, it's kind of hugging the ecliptic. And the reason for that is that it has an extremely high inclination of 175 degrees, which means, again, like A6, going around the sun in the opposite direction. Atlas is going around the sun in the opposite direction as well, but it's almost exactly the opposite direction as the Earth. So it's actually very close to the orbital plane of the Earth, just going in the opposite direction.
Okay.
And just to kind of show some pictures of the comet that have been taken over the last few weeks, even with, fairly small instruments. And like you mentioned, the
Okay.
tail, and you'll see a giant gas coma.
Right.
And so the reason why all of a sudden the comet appears brighter is because before we were probably only seeing the dust coma, little thing, and now we're seeing much bigger gas coma. But you're also seeing a
Yep.
most likely dust tail that's forming there and kind of trailing away from the comet. Now, in the few weeks after discovery, there was a report saying that the tail was going in the wrong direction, that it had an anti-tail. And right now, the tail's pointed in the right direction. So I
Okay.
think what we were seeing wasn't so much an anti-tail as a sunward fan.
Hmm.
And you see this a lot with, even, again, it doesn't have to be an interstellar comet. Enki shows us every time we see it. When it first turns on, it has kind of an asymmetric coma that's in the direction of the sun. And it's probably just the part of the nucleus that's seeing sunlight as active. And so it's ejecting dust, gas in the direction of the sun. But as time goes on, it kind of develops a more, round spherical coma and then a tail. So that might be what we were seeing with 3i Atlas, was initially a lot of production in the direction of the sun, but now as time has gone on, it shows a more traditional cometary appearance.
Okay.
And this is the most recent image here taken on September 24th, again showing, big, broad gas
Mm-hmm.
coma and a little hint of a dust tail
Yep.
moving away from the sun there.
Okay.
So we still have some comets that we talked about during the Comets of 2025 podcast that were predicted to become, bright comets, or at least bright enough to be seen in small aperture binoculars and telescopes during the end of 2025. There's not much to update on some of these comets. They're still
Okay.
inbound and they still haven't been observed a lot. There's 24P Shamas, which is predicted to become a eighth magnitude object towards the end of the year. And that one seems to be still on schedule to do that. Like a lot of short period comets, they're really faint until a few months before perihelion, and then they brighten rapidly in those months beforehand. So we're still waiting for Shamas to kind of enter that rapid brightening period.
Okay.
A comet that we were hoping would get up to sixth or seventh magnitude, mostly in the first few months of 2026, is C2024 E1 Verschoss.
Mm-hmm.
This comet has been brightening at, actually, it's kind of amazing. It's been brightening at an extremely consistent rate for 18 months now,
Hmm.
but it's not a very fast, consistent rate. So it's looking like this comet will probably peak around magnitude 7.5, magnitude 8. Though even when it's at its best, it's more of a southern hemisphere object.
Okay.
Though we will be able to see it a few weeks after perihelion, probably when it's already faded to eighth or ninth magnitude from the northern hemisphere. And that's not till a few months into 2026. So we'll talk about this comet a lot more during the Comets of 2026 podcast.
Okay.
And then another recent discovery that we didn't discuss last time because it hadn't been discovered yet was C2025K1 Atlas. And this is a comet that right now it's only about a week from perihelion. And perihelion's at 0.33 AU. So that's even closer to the sun than both R2 and A6. And this comet is surprisingly still holding together. For one thing, it's unlike A6 and R2, which are dynamically old long period comets. They've been around before. In fact, they've been around only a few centuries ago. It looks like K1 is a dynamically new long period comet,
Hmm.
which means this is its first time passing through the inner solar system. So this may be the first time it's been this close to the sun ever,
Oh,
or at
wow.
least maybe in billions of years. These comets have a habit of disintegrating. So the and it doesn't help that it's intrinsically a pretty faint comet. I mean, here's a
Hmm.
comet getting down to 0.33 AU, and it's even now only around magnitude 10.
Okay.
So it's not a very bright comet, and it's currently too close to the sun to be seen. Hopefully, in the next week or so, we'll pick it up in the SOHO coronagraph
Mm-hmm.
instrument images, and hopefully the comet will still be there, but it may only be eighth magnitude, which means it may even be too faint for the coronagraph. If it holds together, if it doesn't disintegrate, and I have to admit that's kind of a big if,
Mm-hmm.
it does pop back out. Here we are in October. It's pretty close to where the sun is. Sun's in
Mm-hmm.
Virgo. In November, it rapidly rockets out of the twilight sky into the northern sky. But we're still talking about a comet that might be at its best 8th, 9th, 10th magnitude at this time. So
Okay.
hopefully it'll be something we can see in the morning in November, in the northern hemisphere at least.
Okay.
And as for that, there was another comet that was recently discovered, C2025 R3 Pan-STARRS. Again, small perihelion distance, but it's looking intrinsically faint. We'll talk about that one a little later if it actually turns into something brighter. Right now, it's not expected to become bright. And yeah, there's objects to look forward to in 2026. Like 10P Temple is having a great return,
Okay.
the periodic comet.
Great. Well, Carl, thanks for giving us an update on these comets. Hopefully, at least one of them turns out to be fairly nice that we can see here in the Northern Hemisphere. But we will chat again in January for the comets of 2026.
Sounds great. Looking forward to it.
All
Yeah, and
right.
hopefully we'll discover that great comet is just So I'm going to find it tonight.
Oh, that'd be great. All right. Thanks for coming on the podcast again.
Thank you, Tim.
Well, that's going to wrap it up for this special edition episode of the Observer's Notebook podcast. I really want to thank Carl Hergenrother for coming on today and giving us an update on these new comets in the sky. Please, let's get out there and observe them. And if you do, send all your observations to Carl. If you enjoy this episode, please take a moment to give it a thumbs up and subscribe and share the podcast. It really helps us reach more listeners. New episodes of the Observer's Notebook come out on the 1st and 15th of the month. You can find us on iTunes as well as the ALPO YouTube channel. You can help support the podcast through Patreon for as little as a few dollars a month. For $35, you'll receive benefits, including one-year membership to the Association of Lunar and Planetary Observers and producer credits on the podcast. The links for our Patreon page and ALPO are in the show notes. I'd also like to extend a special thanks to our producers, Steve Siedentop and Michael Moyer, for their generous support of the Observer's Notebook. And as always, you can reach me directly by email at tim.robertson@alpo-astronomy.org. Thanks again for joining us today on the Observer's Notebook podcast. Clear skies. You can join the Association of Lunar and Planetary Observers today. It's just this easy. You can become a valuable member of this International Lunar and Planetary Astronomy Organization, founded in 1947 by Walter H. Haas. It's based upon the structure of the British Astronomical Association. You can join various lunar and planetary observing sections, contribute to our massive archive of observations. You'll have access to our extensive lunar and planetary gallery of over 20,000 photos and observations of the sun, the moon, comets, meteors, and the planets. You'll receive our quarterly publication, the Journal of the Association of Lunar and Planetary Observers. You have the ability to join the ALPO training program, which will teach you the finer points of making planetary observations. You can attend our annual virtual conference, and you'll have access to the Observer's Notebook podcast. Membership begins at only $22 a year. The way to find us, just go to your Google and type in ALPO Astronomy, and you'll see this prompt come up. There's our association with our website, alpo-astronomy.org, and you'll come to our homepage. If you look at the top of the homepage, it says Join ALPO. Click on that, and you'll come to the sign-up screen. It gives you the information on the organization, and there's two ways to join. You can join by mail, where you will download a membership form, or you can pay online using PayPal. This is the PayPal processing page. You just fill out a few information lines, and then you're given the chance to click PayPal and join the association. Welcome to the ALPO.